In this problem, we're going to find what 3 times the vector PQ is. Before we can use multiplication, we need to figure out what the vector PQ is in component form. Last week you learned about a formula for head to tail method. I'm going to rewrite that down. It was x2 minus x1, comma, y2 minus y1. Next thing I like to do is I like to write down the points that I'm going to use for this problem. P, 1, 0, and Q at 3, 4. In this formula, since it is head to tail, our Q is our sub 2's and our P's are our sub 1's. So P, 1 is x1, 0 is y1, 3 is x2, 4 is y2. And now we'll just start to plug these things into the formula. Three minus 1, comma, 4 minus 0. Cleaning up these differences, 3 minus 1 will give us 2. 4 minus 0, 4. This is the vector PQ in component form, but we're looking for 3 times the vector PQ. Your notes this week, you learned the following formula for scalar multiplication of a vector. K times a vector, generically we're just going to call this guy U, is the same thing as K times its components, AB, is the same thing as the components being Ka, comma, Kb. What this formula is stating is that if you're multiplying a vector in component form by a scalar, a number, all we have to do is distribute that scalar to each component. So applying this formula, we find that 3 times the vector PQ is going to be equivalent to 3 times 2, 3 times 4, and now we'll just clean up these products to give us the vector 6, 12. And this is the resultant vector that we were looking for. If in later problems you're multiplying your scalar as a fraction, you may have to reduce these products into their simplest form.